Hello, welcome to the third part of week 6 of the ECE 9013 course. In this part, we are going to discuss a new data object type, which is dictionaries, and provide some examples on the possible operations that can be applied to this object type. As an example, to illustrate the benefit of dictionaries, we can use the notion of students in courses. So here, for example, we define 3 different lists, one for the student name, one for the student grade, and one for the course. So we would actually need to create a separate list for each item, and each list must have the same length. And information stored in the lists at the same index, each index refers to information for a different person. To be able to update or retrieve student information, we would actually have to maintain multiple lists and pass them as arguments. So here, for example, if we want to get the grade, we need to give the student list, the name list, the grade list, and the course list. And from each one, we would find the student that we are looking for and extract the grade, the course, and return it. And so this is not computationally efficient and it's much harder to debug, because, as mentioned, we need to maintain multiple lists and pass them as arguments, and we always have to use index using integers. We can do the student information using nested lists or tuples, such as shown in this slide. However, in case we use tuples, they are immutable, which means that we cannot make any modification to them. And again, we face the problem of always having to use the index as integer. A better and a cleaner way to do that is through a dictionary. So this is because it's nice to have the index item of interest directly rather than an integer. And it's also nice to be able to use one data structure with all of the information rather than a set of separate lists. So in a list, we would actually have the index and the corresponding element. However, in a dictionary, we can have what we call the key, and then we have the set of elements. So to define a dictionary in Python, we first define it with empty braces, and we store the data as pairs of a key and a value. So here, for example, for the grades, we define it as a dictionary. We define the key to be the first value separated by a colon, and then the value. Then the second key, which is, for example, the second student, semicolon, its value, and so on. So to search for a particular value, we can use similar indexing in a list. However, we can look at the custom keys to be able to search, and we return the value associated with the key. If the key does not exist or is not found, we get an error. So for example, if we define the dictionary as follows and look for the grades of Ed, the output would be A+, because that's the value associated with the key Ed. However, if we search for grades of Sylvia, we get an error because there is no key within the dictionary of value Sylvia. Now, to add a new item in the dictionary, we can actually add this entry using the assignment operator. So for example, in this case, we can add for a key, Sylvia, the value A as the grade. We can also test if a key exists in a dictionary. So for example, if we put the condition add in grades would return true. But if we check whether Dan is in grades, it will return false because we don't have any key with the value Dan. Also, we can delete an entry using the del operator, similar to what we can do in a list. Other operations possible is the dot keys and dot values. So the dot keys method would return all of the keys within the dictionary. So in this case, for example, Dan, Kyle, Ed, and Dana. And if we get or call for the grades.values, we get the value column, and it returns like a tuple for us. So values within a dictionary can be any type. They can be immutable or mutable. They can be duplicates, and they can be lists or even other dictionaries. However, for keys, they have to be unique. They are an immutable type. So, for example, if we need an object that is hashable, but we can think as immutable, as all immutable types are hashable. So, that's why we need to be careful with float type as a key. Also, it's worth noting there is no order to keys or values. So as a comparison, lists are an ordered sequence of elements. We look up elements by an integer index. The indices have an order and the index is an integer. However, in the case of a dictionary, we match keys to values. We look up one item by another item, so we look up a value using a key. There is no order that is guaranteed, and the key can be any immutable type. In the class lecture, we will be showing an example for this. Thank you.